Welcome for coming to our sessions on Knative Eventing. I'm Mark Chmarny. I'm one of the technical program managers at Google looking after serverless.
And I'm Ville Aikas. I work on the Knative. I've been working on it from the beginning, and most recently I've been working on the eventing side of the Knative. So that's what we're talking about today.
First of all, thank you for coming. I know this is the last day of the conference, and even getting this audience here is great. And it also is going to be a 300-level session. So we're going to go a little deeper in technology. We're going to do all kinds of demos, at least two demos, maybe three. There's going to be kubectl commands, there are going to be YAML, so definitely lots of fun. The other thing I want to kind of quickly just give heads up is we've recently, this week, we dropped a new version of Knative. So everything we're going to be showing today is based on that version of Knative that just landed this week. There is a blog post that we published earlier this morning that overviews all the new features in 0.5 of Knative. Don't read right now, but later on. By the way, the Dory is also open for this session. So Ville and I are here, obviously, so we're not going to be able to answer real time. But as soon as this is over, we'll jump in and provide answers. And hopefully we'll have some time also to take real time questions. All right, so very quickly, I know how many of you have worked on or touched Knative or used Knative, worked on Knative in any kind of interaction with Knative? All right, so we have some people, but not many. So why don't we take a quick kind of level 100 overview of Knative for about 3 to 5 minutes, and then we can go deeper so once we level set. First of all, Knative is a set of open source building blocks that are specifically kind of oriented for building serverless on top of Kubernetes. What that means is that last July at this very conference, we have launched Knative as an open source project, and we had at that time 4 other partners who worked with us on that. We were very much focusing on those building block concepts, knowing that people can pick and choose those components that they needed, but we also saw a lot of commonality that people were working on in the community. And while they were very interesting and complex, they were also not very differentiating. So people were often not being able to get as user-friendly experience using building serverless on Kubernetes as they normally would. So we launched this. It's on GitHub under Apache 2 license. And right from the start, we focused specifically on 3 areas initially, but the space is growing. We focused on building, which how do you get to an image that you can actually use on Kubernetes that would be friendly for serverless type of workloads. We focus on eventing, which we're going to be talking about today, and we focus on serving, which is clearly how you're going to be accessing the serverless stack at that time. So very much still focusing on these modern type of workloads. What that means is that if you have like a stateful application, this might not be a good fit for Knative. But if you're working in a kind of modern stack, 12-factor applications, microservices, this is very much kind of geared towards delivering the best experience of developing on top of Kubernetes for you. It also includes 10+ years of building serverless stack at Google. So all the learnings from those products are kind of applied in here, both from Google as well as number of partners in the community. So that's pretty exciting. So very quickly, I'm going to overview each one of those components. So we had a serving, build, and events. For serving and build, very quickly, so there's a couple of benefits that developers get from Knative today. First of all, the one that we always stress is this automatic auto-scaling. Basically, you deploy the workload, and we take care of this underlying auto-scaling based on requests or usage of that workload, not on something like CPU, which might be more traditional way of auto-scaling for Kubernetes. And what that means is that we can auto-scale through activation when the request is being made, and then we also can scale it down to 0 when that workload is not being used, which is very helpful for obvious utilization reasons. So if you have a Kubernetes cluster, that cluster can be used to provide other services or resources that can be managed through other workloads. The other very interesting part in serving is that we kind of, from the day one, focused on looking at deployments as a combination of configuration and the actual code. So it goes in unit, we freeze that, we identify it, we manage it for you. And what that means that at any given time, you can roll back, you can deploy a new version and roll back to the last previous known state, knowing that it will go with the configuration that was true at the time. If you've been building applications, the very common pattern that we see over and over is you come to a conference like this, you've seen some new language, new framework, new service, you get excited, you build that service, it goes live, you startling get users, yay, it's exciting, and now you find out that there is a bug. Well, I would. You write perfect code, so that would not be the case for your code, obviously. But and now you need to update that application, but you have users who constantly use it. So one of the things that Knative enables you to do is provide a way to manage that and provides patterns like blue-green, which allows you to shadow a new version behind and switch the traffic to a new one, and also use some kind of experiment framework that will allow you to incrementally switch the traffic to a new version. Switch the traffic to a version that's not exposed to the users and with a name route access it, or any combination in between. So a lot of good learnings there. The access control is the last one I list there, but this are just highlights. So obviously we can go deeper on that at any given time. There's a lot of documentation. So this deals with the fact that you might have, if you're building microservices, sooner or later you end up with 10, 20, and if you're doing it for a while, it's going to be hundreds of microservices, and only one or two of those need to be externally accessible. With the request access path control that's integrated based on Istio in Knative, you can manage that by not exposing routes to services that don't have to be externally accessible, so it's very helpful. On a build side, right from the day one, we were focused on delivering reproducible builds. That comes very critical if you want to be able to assure that the same version of code built multiple times can result in the exact same image. And it also enables us to start kind of exposing through build templates ways for people to optimize different frameworks and different languages for build pipelines that allow developers to go directly from source all the way to a URL. So yes, there is an image in between there, but the developer doesn't have to see it. Eliminates a lot of pain around cross-compiling, like number of flags. I know like in Go it's not too complicated, but if you go to Java, you want to compile from Java on a Mac to Java on Linux, you might have some different challenges there. And also removes the need for Docker entirely on your workstation because it's built on a server. So you send your build job, it compiles it, it builds that image for you, and handles the entire thing. And because it's a cloud, it runs on top of Kubernetes, you have access to all the caching and all the elasticity of that framework, of that service. And you can leverage big VMs for the build process, and you can decommission them afterwards and use other nodes that maybe are more optimized for bursty type of workloads. So that's excellent. Very quickly, this is just high level over here because for the rest of the session, we're going to go deep into the eventing. So eventing, more than anything, is all about orchestrating the actual events on your cluster, both for the event sources that happen externally to the cluster as well as if they happen on a cluster itself. One of the things that we also focus from the day one is making sure that that experience for the developer is very declarative. So you don't go in, run some commands that then suddenly you have to rerun if the nodes change, but you tell us the state that you want, and using the same principle that's applicable to the entire Kubernetes stack, you get that event registered and bound for you. Higher level objects made it much easier to reason about, so you can kind of always come back and interrogate your configuration, understand what exactly has happened, even though you might have set it up 2 weeks, 3 weeks ago. And because it's built on top of those Knative events are built on top of serving, you continue getting access to that dynamic scalability. So it allows you to build this very simple trigger demonstration we're going to show in a minute here when you wire some kind of event directly to a service and just fire it automatically, all the way to a very complex pipeline. And every day I'm amazed by what people are building. Channels, triggers, filters, fan-outs, all kinds of stuff. All of that is based on open standard for event transport. So cloud events is what we utilize inside of Knative. And on the end of the day, is extendable. So what that means is that yes, we have I would say about 20 different sources that are already published on the Knative website that are built by the community. You can consume those, you don't have to build this, but you know what, if one of one of those that you need is not there, you can always come back and build a new one. And Ville is going to show you later how relatively easy that can be for different kind of use cases. So without further ado, let's talk about eventing.
Thanks, Mark. All right. So so we are really excited to go ahead and be here and talk about the new eventing model. We have spent several months in looking at the use cases, how people use the objects that we put together in the, 0.2, 0.3 release, and getting a lot of feedback from the users on those, and hearing it loud and clear that they're pretty tricky to put together. When we started the serving stack, it was a little bit easier because Kubernetes had a lot of primitives that we could use, and they lent themselves quite well for building the serving stack. For the eventing, not so much. So we had to do a lot of work on there, making sure that those primitives are right so that we can then build something really neat on top of that. So we are going to talk about the two new objects that we introduced. If you have used the eventing before, there are other things in there. But these are the two new ones that we talk about because we think they make the most sense as a user to go ahead and reason about the state of your system and to make it useful. So really, the developer cares about one thing and one thing only, which is to go and say, I want to go and take events like this, and I want to send them over here. If you think about it like that, that makes sense to me. So you don't really care about where those events came from, right? That should be a detail that you shouldn't have to worry about. You're like, I just want to go ahead and know when an object is uploaded to my storage, for example, and when that happens, do the thumbnailer, the classic example. But you do, however, care about how these events show up in your function. And as Mark mentioned, we are using cloud events, so it's a CNCF spec that a lot of companies are working on, including Google. So we are standing on the shoulders of the great work that other people have been doing. So we want to go ahead and emphasize the fact that you as the function developer can go ahead and have a standard way of consuming these events. So you go ahead and get the cloud events. And by using these two new models with the broker and trigger, we are really unifying the consumption, which is where you say, hey, I would like to go and receive these events and put them over here, a function or whatever. And then it also unifies the event production side of things, and we'll talk a little bit more about that one. But there's a really nice model so that you can think about and reason about the system at the high level. So let's look at these two objects a little bit more in detail. So developers are probably going to use this resource the most, which is really allowing them to go ahead and say, hey, when this event type happens, please call this function over here. Today, so some examples of this would be like, hey, when a PR is put into a GitHub, then do some things with that, right? And we actually use this. We use this in the Knative repo. We have many of these little robots that do things like fix spelling mistakes or go ahead and make sure the YAML looks right and things like that. So we are using this in the Knative, and it's really, really neat. So that's a good example for that. Or you might want to say, hey, when objects are loaded into GCS, I want to go and receive those, but only certain kinds. So that's the concept of the filtering there. So the other nice thing is that in this model, the trigger or your function code can actually go ahead and just return a new event type. So if you, for example, want to go ahead and say like, hey, I want to take some kind of an event, but it might contain some sensitive information that I don't want everybody else to see, you can go ahead and either create a new event or event type, and then you can go and feed it back in the system. So it makes the function writer's job much, much easier on that sense. So in this particular one, for example, we are saying, hey, I want to go and receive events from com.example.some event, and we are sending it to a subscriber. And if you're familiar with Kubernetes or Knative, that is basically an object ref. In this case, it is using a serving service.serving. The other new event is the event broker. And this is really, I personally think of it as the event delivery system or the mesh. So when you come into a namespace of your choosing and you decide that you want to sprinkle some Knative eventing on it, you can just go ahead and apply a label on that namespace, and the Knative will install a broker for you in that namespace. And as a side effect of that, you will now get a discoverable endpoint / predictable endpoint so that you can go ahead and now target that event mesh from any other namespace or from the same namespace as well. You can also install multiple of these as well into your namespace, or multiple namespaces. And you might say, well, why would I want to do that? And really, there's a couple of different reasons. But one of the things that happens underneath the scenes for the broker is it has to manage some messaging layers. So these are the channels if you've been using with the Knative Eventing in the past. And you might want to go ahead and choose a couple of different broker models. So in one of them, you might want to say, I don't want to lose any of these events, so I'm willing to go ahead and pay the cost of persisting them into persistent messaging. And the other one is where you might just be doing you don't care, and you might choose to go and do things like in-memory implementation, where if an event gets lost, fine, rerun it again, or whatnot. So you have some options there, but you get it for free if you just label the namespace. And you can also go and use the broker object as for controlling access and ingress policy into that broker. So you can say, for example, I don't want any events that I have not pre-authorized to enter this broker, and that's one example of that. The other one is where you're doing some cheap and cheerful testing, and you just want to do stuff, produce events willy-nilly and everything else. So good luck with that. The last one that didn't unfortunately make it to 0.5, but I just wanted to point out here is that this is the registry that we are working, refining as a community right now, making sure it's nice and usable. And really, it's meant to solve the use case of how do you discover the event type. So once you're in your broker namespace or in your namespace, you want to be able to have an easy way to discover what event types there are, what do they look like, and so forth. So this is something that the registry is going to solve, and we are working very hard to get it into the next release. So this is what it really looks like, or at least how I see the world. So if you think about from the left-hand side there, we have two event sources that are producing events. And they both, so there's the red and then there's the blue source, and they are both pushing those events into the broker, where the broker is happily receiving them. And then a developer comes in on the right-hand side there and defines one of those triggers where they come in and saying like, hey, I am actually interested in the red events. So you create a trigger where you specify that the filtering is red, and now your service gets called only for the red events, and on the bottom side, you can probably guess that then that one gets only the blue events, right? In the both cases of the service, I just highlighted the fact that it's callable because it's using something that in the Knative we make extensive use of to make it easy to extend and pluggable. It's a duck typing concept that Matt Moore and I have been working on for a while. So the nice thing is that you can put different kinds of things. One of those is a Knative service from the serving stack, but you can use you can put these things into other places as well. So let's go ahead and see what this looks like in action. Mark has cooked up something neat.
So before we go there, a little setup here. Now this diagram looks very complex, and we will kind of break it down. I kind of put a little line around this where we're going to be focusing today. What we're going to do is we're going to create a very simplistic trigger that will fire on a PopSup event. PopSup is a very simple, globally distributed event messaging system that's easy to consume. So what we're going to do is we're going to create a simple trigger that will fire whenever a new event arrives. But I wasn't going to create new events myself. So what we're going to do is actually going to leverage one of the events that are already generated by Cloud Build. If you attended some of the Cloud Run demos, I've used that demonstration there. So we will fire a simple build, and whenever the build publishes a new status of a build, we'll attach to it and fire an event. Now, events are great, but not really meaningful until you can see them. So what are we going to do in this case? We're going to send this to Slack in order to be able to display the actual content of that. So can we switch to the demo machine? I want to make sure Slack is running too. All right, so first thing what we're going to do is, can you see this? Yeah, it's pretty good. So what we're going to do is we're going to look at the trigger object in here. So if you've worked with Kubernetes before, you should be very familiar with the fact that there is some namespace for the API and the version. In this case, we've created a new object called trigger. That trigger allows us to name it, and for demo purposes, I named it pretty long, but you can name it wherever you want. We're really going with a lot of defaults in here. So we're using the serving namespace to be able to define an addressable object. In this case, our addressable object is going to be our notification service building, the one that we're going to send those events to. So let's go and fire this up. So kubectl apply config, again, very Kubernetes-friendly way of doing it. There's a number of CLIs now that are already available in the community for Knative, so that if you're coming from Kubernetes, you're very familiar with kubectl, you can run this anytime, right? Or kubectl, depends. There's a bottle still how to exactly pronounce it, but if you're familiar with that, you can continue using that. But there's a number of CLIs available that actually hide even that from you and allow you to deal specifically only with the Knative objects. And Knacle or KNCTL is one of those. Knative project has its own CLI being built right now, so you're welcome to try this. But in this case, we're going to go straight to kubectl. We're going to apply this. How's the command line? Big enough? Yeah. So what we've done message is that the trigger was created, but let's not trust those messages. Let's run get triggers. And I'm running everything in a demo namespace just for isolation purposes. But what you will see here is that we got the, let me see if I can make this bigger. There we go. You got the name, the status. Each trigger has its internal URL. Obviously, that's not accessible externally, and the age in here. So what we've done now is we've set up the trigger. That's all I had to do in order to attach myself to the source of events. So let's generate some events now. Very quickly, before we even go there, let's take a look at that actual service. That service is really just for demo purposes, but what it does has a couple interesting things here. First of all, there's a handler that whenever it receives those cloud events, remember we talked about the transport always is in cloud events, so you can trust that the type you're going to be getting is going to be cloud events. We're going to get one of those types, we're going to extract the actual message of that, and then we're going to send it to a sender that decorates nice message, and then at the very end, it just sends it to Slack. And hopefully, if everything goes well, fingers crossed, in our demo, we're going to be able to go in and see the status being published. So let's go to, I have a simple pipeline set up here, so again, I don't have to build anything myself. We're going to create a simple new release. I'm going to div some name, Knative trigger demo. Obviously, you should be doing some better releases, but since you're watching over here, I'm just going to say no. Release, notes, very sad, and submit it. So Cloud Build gives us an easy way to kind of get a kind of peek at what's going on. So there's one fired already. I'm not going to go through all these details of what happens here. Cloud Build gives you an easy way to kind of attach yourself to source repository. This one is firing on a tag. You can do this on branches and all that. But let's go to our Slack and see what's going on over there. Hopefully, this is all public, so it's not like any secrets in here. Knative channel. We see our notification arrived for a next demo 25 starting working. If I waited long enough, if I went to the status and waited for that to finish build, it would eventually send another status change saying, I was working, now I'm finished, and the status, finished status was built. You can actually go and gives you a link in here. This is just a demo channel, so you can clearly see that the message is not formatted exactly perfectly, but once the build finishes in here, you will see one of those statuses change to success. So can we change back to the slides, please? So back to our channels here, those events could be anything. Ville was talking about the number like GitHubs and pushes and everything. The process would be one and the same. You go and create a trigger. You attach the trigger to some kind of event source, and we will go into the event sources in a minute. And then you also send it, who's the consumer of those events? And in this case was a notification service that adheres to that interface, and we send it. So pretty simple, pretty easy. There's a number of those demonstrations in Knative samples, and you can kind of reproduce this pretty easily on your own Knative cluster.
Oh.
Nice. Good catch.
All right. So one of the things that we didn't talk about yet, but let's talk about them now. So we really focused on what the developer experience is there, where they can come in and say, like, hey, here's my trigger. It was very easy to set up. You basically just said, I want those kind of events. I want them to go over here, right? That was nice. There was no mention of how did those events show up in the cluster, okay? And it's not magic. It turns out we haven't figured that out. So there is some stuff you have to do to get those events into your cluster. And by utilizing these event sources, the user is going to care about a couple of different things. They're going to care about, OK, how do I actually get those events then, right? So you want to be able to discover these event sources. So for example, if you're like, OK, I really would like to go ahead and build my own little GitHub robot or whatever else, so how would I do that? So you want to be able to discover that there is a GitHub event source out there for you, right? And you also want to be able to configure those external event sources, because you have to be able to do things like, for example, in the GitHub, you want to be able to say, I need to go ahead and watch for events on this particular bucket owner or repo, project and repo, and you want to be able to specify those ones. And lastly, you want to be able to go and say, but that's great, but I have my own internal system, and I'm sure nobody's going to write an event source for that. So you always have the option of writing yourself and be able to go ahead and use it internally, but hopefully you can come in and write some other external ones and come play with us. So Knative Event community has already built many of these. So here's just a very, very small sample of the ones, but you can see the rich set of event sources that you can go and come in and start using today. But many of these are in the repo. Some of them are in the different kinds of repos because they are maintained by different people and so forth. But on the bottom, there's a link that contains all the event sources. And if you write one and you want to go ahead and come in and expose it to a wider set of users, then you can go ahead and add it to the list and just send out a PR. So let's go ahead and see what does it look like to go and actually go ahead and use one of these event sources. So first demo, we talked about events were already wired up to come into the broker, and all you needed to do was to go ahead and create a trigger to go ahead and consume those. So now let's go and complete the picture and saying like, yay, OK, now let's go and look at that magic, which is not magic. But what does that look like when I go and say, please give me events of certain type? So Mark?
All right. So again, back to a quick overview before we get there. I'm going to trust you today. I'm going to ask you to actually use your devices to post something so we can display it in here. Ville is going to hold a finger on closing the window whenever something doesn't work. I'm sure the HR team is going to come and send me an email afterwards. But what we're going to do is we're going to create a very simple, we're going to configure a brand new event source for tweets that are matching a specific query. You can guess is going to be, I will tell you the query in a minute, so we don't have too much time. The other thing we're going to do is we're going to go in and configure the same different trigger, but using the same pattern. We just have done this for the build status. So we're going to create a source, and we're going to create a trigger. Then we're going to open a Knative service that's a basic UI application that's going to display those tweets. Now, you have to be authenticated to Twitter, so we know who you are. But I'm trusting a lot into this whole process. All right, can you switch to the demo? So in this case, back to our YAML. You're going to be in a YAML a lot if you're working on a Knative. We're obfuscating a lot of that through a CLI sometimes, but in some more complex cases, you still have to use YAML. So in this case, we're going to use a brand new object type called container source. Ville will talk about those. That's one of the types of sources that we can integrate into Knative. As you can guess it, I called this the Twitter source. Here's your handle, so start typing. Please. Don't get me in trouble. The other thing we're going to do in here is we're going to actually start using some more advanced features. So for example, in this case, I wouldn't want to show you, especially when it's recorded, tokens for my account to connect to Twitter, right? That would not be wise. So we're using Kubernetes secrets. That's something you can do. We can use both Kubernetes secrets as well as volumes, if that's a more easier pattern to use secrets. We're going to deploy an image that represents the actual source that's going to be consuming this. We're also going to do a couple other things in here. We're going to create a broker, and we're going to go to a default broker in here. So let's switch over here. And the first thing we're going to do is, so this is source, yeah. Let's deploy this. Again, let's get the sources. Come on. There it is. So we see the original PubSub that I was using in a previous demo, but here is my brand new 11-second-old event source for this. So that's one. The other thing we're saying we're going to be doing is we're going to be creating a trigger. You already seen a trigger, so I'm going to focus on a couple new bits in here. First, we're adding a filter, saying there could be n number of different types of events, and Ville talked about those different types when he was overviewing the trigger. What we're using in here is all I want to subscribe to is those Twitter triggers. A lot of T's, sorry. So what we're going to do is we're going to define the type. This is really an opaque string, but it's using a pattern that's kind of common for these events, com.twitter. And we're going to send this to a UI event that looks like this. So hopefully, when everything goes well, a very nicely formatted and clean tweet's going to show up here in a minute. All right. Let's do, we have to install this. Nothing happens until you actually do this. So let's clear, kubectl, apply, config, and this is the trigger. And to make sure we're going into the same demo. All right, so this is created. Let's just make sure it's there. I don't know, I should be trusting Knative to just be there for me. It never disappoints me. All right, so. Yeah. I should close this right now. So you can build a very robust set of features. Can we switch to slide? Thank you very much. Jay Troson, thank you very much. What we've done the entire pipeline by creating brand new source. Ville is going to overview how to create the actual source itself, the code, but we configured that source on a cluster. We then went in and created a trigger. You can have n numbers of those triggers that listen to that same source. And we've defined the trigger that connects that output of those events, or the events themselves, and fires a particular event. So anything targetable will work there, and Ville will overview what that means. Right now, simple service was a good example of that. We were using also WebSockets example of here that was able to kind of refresh the page without me doing that. That's a new couple new features, couple new transport supports that we've added, including gRPC, HTTP2, WebSockets. Am I missing anything? No. All right, so simple demo, easy to follow. You can easily reproduce that one as well as many other ones, again, in samples, Knative repository in a samples repo.
Thank you. All right, so there's a couple of nice things that you get out of using event sources, right? So if you have used GitHub or Twitter or any of these other systems that already produce or are capable of emitting events, you can go out today and go to some web page or tools and create these for yourself and point them at something else as well. But with the event sources, the benefits of using them in this way is that it actually means that they're declarative, right? So you can go ahead and create these in your cluster. You can actually see them. So as Mark was showing there, you can say, what are the subscriptions that I have going on for me right now? You don't have to go ahead and remember how things are done, in a sense that, creating webhooks in various websites, it's always different, and it's difficult to remember how they were created, and there's all these how-to pages and so forth. So by using the eventing sources, you can do this all declaratively. You can check in the configs into your source control, which I'm sure you are all doing because config is code. So you are doing all the right things. And they're also reconcilable. So if you make changes to those event sources, then all the right things happen for you underneath. So the source is then responsible for taking care of that on the authoritative side. So that's really, really nice. And the last bit is that there's now a very clear separation of concerns, so that the broker is basically creating a nice little eventing mesh that takes in all the events, and then the user focuses on routing those events to the appropriate functions by using triggers. So that's nice. And then on the other side, we have these event sources that are responsible for then establishing the control plane and the data plane and ensuring that those events are now delivered in the broker. So there's a nice little clean separation there. So while the Knative community has provided many of these event sources already. As I mentioned earlier, there's probably some that we haven't done yet. I know there's a lot of them that we haven't done. And you might also have some internal systems, right, that you want to go ahead and say, it would be really nice if that thing that I already have would produce events for me. And we think that saying, great, just rewrite it so that it's cloud native is probably not the best answer. So we can go ahead and make sure that we can take these bits of code in the form of event sources and kind of bridge those two worlds together. So let's look at a little bit at these and see what is sort of kind of involved in building one of these event sources. So there's really two concerns that you have to think about. So one of them is the control plane. So the control plane is the one where you are asking some external system, external to brokers. When I say external, I don't really care whether it's internal or external, but I do think that it's outside of the broker's realm, so it's external to broker. So there's a control plane action where you are asking some system to go ahead and start sending you events that are filtered according to your specification. So here are some examples, creating a GitHub webhook for a particular repository and defining what kinds of event types you might care about, so PRs, commits, comments, and things like that. Or creating a GCP pub sub subscription or GCS object storage notification and so forth. I'm sure you can all hopefully think of a couple of other systems that are not on that list. And then there is also the concern about the data plane, right? So it's great that you have asked somebody to send you events, but where are they going to be sent to, right? So that is the concern of the data plane. So in this case, for example, we can go ahead and create a data plane component that receives the GitHub webhook events. Or we can go ahead and have a piece of software that is running on our cluster that is responsible for handling pull models, because there's both kinds of models out there, right? So there's push and pull-based ones. So, so on the control plane, while on the broker side of things, we are standardizing on the cloud events, and there's a nice little control plane component there that allows you to do that. There is nothing like that, unfortunately, out there that allows us to go and have a standard way of subscribing to events everywhere, and I don't think that that's going to happen anytime soon, but maybe that'd be nice. But if you look at, for example, when Mark was demonstrating the Twitter example, right, there was things that he had to go and specify, like, I don't know, credentials, right? So credentials come in different kinds of formats. So the control plane has to be customized for a particular event source so that it knows how to authenticate itself and so forth. They also all have different custom APIs. The nice thing is that many of these, there's many libraries that you can go and pull in the form of your own choosing, language of your choice. And then it also has to reconcile. So I mentioned earlier that if I make changes to the Twitter example and reapply those changes, then the Twitter source is going to be responsible for pushing those and modifying the control plane bits as necessary. And the second bit that the control plane needs to do is, as it is setting up the control plane, it obviously needs to go and point it at something and establish the data plane. So the event source is also responsible for setting up the data plane components. And a couple of reasons for that are, well, there's probably some authentication that has to happen at the data plane also, right? So if you, for example, set up a GitHub webhook, then one of the ways that you can authenticate there is by using a shared secret. So the source is going to go and set up a rando secret, give it to GitHub, because nobody else cares about it, gives it to GitHub, and gives it the data plane, and you're off the races. And then obviously control plane needs to go ahead and clean up after it's done. So once you decide that maybe you don't want this anymore, it's responsible now for going in and deleting the external sources so that you don't have to remember, say like, oh, I don't want to receive those events. Now here's a piece of documentation that tells you how to undo all the stuff that you did before. So really, this just a simple picture where the event source on the left hand, the yellow ones, those are the custom pieces of code that run on your cluster. So there's two of them there. There's a GitHub and a GCS, and both of them are talking to a control plane. One of them, the GitHub API, using the green one, and one of them to cloud storage. And they are just establishing that data plane on the right-hand side there to the broker. That's what they're conceptually saying. Please go and send those events. Send them over to the broker over there. Well, that's nice. But then this is where you have to worry about things like the data plane, right? So while everything within Knative, eventing is cloud events, so the broker says, I only take cloud events, right? Again, nice separation of concerns. So the data plane is going to have to normalize those events that are coming in from the external sources, convert them into cloud events, and hand them off over to the broker. They also need to, as I mentioned, deal with the authentication and authorization. So just because somebody sends you an event from the outside world, you want to make sure that it actually is the one that you subscribe to. So that's where the coordination between the control plane of the event source and the data plane, there's some coordination that needs to happen. And again, there's pull versus push. So some examples are, for GCP PubSub, you can run in both modes. You can run in pull mode or push mode. So depending on how you want to go ahead and set up your data plane, you have choices there. Push-based obviously lends itself very nicely to Knative serving, so that many of these event sources that are push-based are implemented using just a Knative service. Yes. Yes, and so it roughly looks like this. So that we have kind of covered everything about the broker anyway on. So these, the first part was the control plane, the yellows. Now here's sort of kind of the data plane for you. So you can see that the, for example, the FTP receive adapter that we have written, for example, is the one that is pull-based, because many of the FTP servers out there don't expose a push-based model, or they don't expose any notifications, so you have to go ahead and do something like this. But this is a good example of being able to take a little bit of glue code and saying, you know, now all of a sudden, without changing anything on the original source that you cared about, you can go and write a little bit of shim code and go and bring those eventing capabilities now to an existing system out there. And then GitHub and GCS, so they're all sending different kinds of events. Off they go into their respective receive adapters, and out comes nice, normalized cloud events that then can hand it off to the broker. Obviously, they contain different kinds of payloads. So if you look at the one on the bottom there, there's a quick example of sort of kind of what do these magical cloud events look like. So there's kind of a standard envelope around it, and then the payload goes in the data there. So it's very easy for the function writers to go ahead and reason about these.
7 minutes.
All right. So there's basically 3 standard ways today to go and write event sources. So one of them is the, hey, I want to go ahead and do it all myself. I want to write a Kubernetes controller because that is fun. And that's a lot of work. So we came up with something called Knative Container Source. I'll talk a little bit about that one. And then the last bit is where you already have some running code that you have control over, and you want to go ahead and just start emitting events from there. So the Knative, the Kubernetes operator is basically, this is a standard way that you basically add a new object type into Kubernetes. You basically define a CRD that says this is what the objects look like. And then you write a controller that sits there and looks at those objects and reconciles the world. And then you have webhook that is authenticating and validating and defaulting and things like that. So it's only 3 pieces, but it's a lot of work. Trust me, I've written a few of these. So that's a lot of work, and it's very complicated to get it right, and so forth. There's a great example that actually uses this, which is the GCP PubSub controller. So I'm not going to go through the code, but there it is. You can go look at it. So what we did at the Knative, we're like, okay, look, it's really, really hard. So let's go ahead and write one controller that is easy for you to reason about, because you just say, hey, when a new event type gets created, like the Twitter. So a good example, this is the Twitter one. So when we showed you the Twitter one, this is the Twitter source is using the container source. So you basically just say, like, look, I don't want to write a Kubernetes controller. I'm just going to give you a container. Can you run this for me when you go ahead and establish a new subscription, modify it, and delete it? So that's what you can do with the container source. You just give us a controller. container, and we run it for you. And the nice thing is it's language neutral. So you can, whatever code you have, just wrap it up in a container and bring it to us. And with this model, you can also go ahead and it's possible to combine the control and data plane. And one example of this is the Kubernetes event source. So this is the Kubernetes event source that runs on your cluster. It watches for Kubernetes events and turns them into Knative events for you. So then you can go and do things like automate some aspects of your Kubernetes cluster yourself and things like that. And there's obviously more code here, but really, and there's a link to it. But the only things that it really cares about, it sets up the control plane on there. It basically uses Kubernetes client and says, hey, I want to go ahead and start watching for event types or Kubernetes events. And when those events happen, please call this little function for me. And all that, and that's the add event function there. And the only thing that function has to do is take that, wrap it up in a cloud event, and ship it off the broker, and you are done. So that is a pretty simple one to do. And then let's say you already have some code running, and this is our super secure login service here, for example, where the only thing we want to do is we have some running code, and we have some places where we would like to go ahead and extend that system by emitting some events. So all we have to do is from that existing code, decide where we want to send the events, when we want to emit events, and instantiate a new Cloud Events client. So in this case, it's our own internal events. I just wrap it up in a Cloud Events, and my data is then whatever you want it to be, right? So those are the kind of the three ways of doing it in the order of decreasing difficulty, if you will. And there's Cloud Events SDK. There's one good example, the Cloud Events repo. As I mentioned, the spec, there is that's a Golang, because this is Golang. But you can use that, so it's pretty easy for you to go ahead and do this yourself if you want to. And
all right, we barely made it on time, but hopefully it give you a good overview of the Knative events and the capabilities therein. It's very hard to kind of go super deep, but also fit it all in an hour and level set. There's a lot of examples that are available on a Knative website. If you go to our knative.dev and drill down into samples, you will see all different simple events all the way to very complex ones, and you can kind of pace yourself. We also have walked through the spectrum of the way you can interact with events. You can start with a very simplistic one where you might not be able to reconcile your sources and migrate over time to something more complex. Again, a lot of those event sources have already been written, so you don't have to be in that business unless you want to. So hopefully this was a good informative session. There's a couple links in here where you can get hold of us, as well as ask some deeper questions on a Knative Slack. It's just access knative.slack.com. That will redirect you to Slack directly, and you can ask the different channels for eventing, community, the general one, which is always a good place to start with. And obviously we have, this week we have kind of announced Cloud Run. Cloud Run doesn't support Cloud Events yet for this kind of service, but as you can imagine, we're looking forward to the time where we can offer that service too. Thank you very much.